Māori have always been scientists, and we continue to be scientists. Our science has allowed us to live, work and thrive in the world for hundreds of years. My name is Dr. Ocean Mercier, and I'm a lecturer in Pūtaiao Māori at the Victoria University of Wellington. My job takes me all over the world to talk about Māori science and how traditional knowledge is being married with Western science here in Aotearoa in order to find innovative solutions to universal global issues. In this program, we're going to show you how these worlds of science are intersecting and how the paths to our future are being formed. He tino taonga te Taewa. Introduced to Aotearoa in the late 18th century, ka tino kāinga e te Māori, with many varieties preserved from this time. Taewa were grown commercially until the late 19th century, and though production on this scale has ceased, they continue to be grown. Neke atu I te whetū te kau ngā momo Taewa. Ahakoa te kore whai pūtea I te hoko Taewa I ēnei rā, it could still have a role in saving Aotearoa's commercial potato industry millions of dollars. The discovery of zebra chip, a potato disease that stains the flesh of the potato when it's fried, spelt disaster for commercial potato growers in Aotearoa. Much of the economic impact of zebra chip comes not from edibility issues, but cosmetic ones. While not hazardous to health, infected potatoes have stained vascular rings and won't be purchased by processing companies. Zebra chip was first identified in 1994 in Mexico. Since then, it's been reported in the United States and Guatemala. New Zealand's first suspected case of zebra chip occurred in 2006 when an Auckland greenhouse reported the symptoms of infection. I ngā rohe tuawhenua o te tonga o Tāmaki I te rangahau ahumāra kai I Pukekohe, tērā Aleise Puketapu he kai rangahau e kimi ana I te tuakiri o te Taewa e tau ārai ana I te psyllid.
I did my Masters of Science degree at Massey University in Palmerston North. My supervisor was Dr. Nick Roscrooge, and my research was based on the life cycle and epidemiology of the tomato potato psyllid on 3 Māori food sources, and one of those was Māori Taewa. The tomato potato psyllid is a small hemimetabolous insect, and what they do is they land on the plants and suck cell contents. As well as feeding on the plant, they actually transmit a bacterial disease called Candidatus liberibactem solanacearum, which is commonly known as zebra chip in New Zealand. There have been reports of up to 80% yield loss, which has huge financial implications for growers.
Kua noho a tākuta Nick Roscrooge, te kaiako o mua o Aleise, te kaiwhakatū hoki I tā huri whenua te rōpū kaiwhakatipuhua whenua Māori, hei pou mō tāna rangahau.
Just by way of introduction about what Taewa Māori are as compared to your modern sort of potatoes, that these are Taewa Māori. If you look at them, they've got a large number of shoots from the seed tuber, but these are the old Māori potato. We call them Taewa, some people call them riwai, peru, different names. This particular one is the moi moi, so a nice sort of healthy looking plant. Alice's work, there's a particular pest that has been getting into all potato crops, so commercial and Taewa, and Alice's work is looking at the impact of that pest and the better management systems for the future. So these are unique to New Zealand. They are potentially commercially a good option.
I te tari o rangahau ahumāra kai I te pokapū o Tāmaki Makaurau, kai te arahi a tākuta Robin Gardner G I te kaupapa a Aleise. E marama ana ia he take nui te ārai psyllid.
What we've got here is the tomato potato psyllid, so a native of North America, and it arrived into New Zealand in about 2006. It was a major alert and alarm went through the growing communities, and there was a major sort of scientific research effort that came in with the growers to try and work out solutions.
The psyllid feeds on plants by inserting its mouth parts into the leaves and phloem of the plant, where nutrients are normally carried. The bacteria transferred by the psyllid during feeding can lead to the infection of tubers in potatoes.
But in a plant like potato, the feeding and the bacteria causes the plant to wither, premature dying, and then the bacteria can get down into the tubers of the plant, and that's where the problems really start, because it changes the carbohydrate in these tuber, and that's what causes what's known as zebra chip. So you take that potato, it might look fine when you harvest it, but by the time it's processed and goes into the deep fryer for your chips, it goes black because of that bacteria that this psyllid has transmitted months ago out in the field. And it's that processing potatoes that have really been hardest hit by the psyllid. There was very little information before we started this work on how Taewa varieties specifically might be responding to the new pest. Taewa aren't part of the mainstream commercial crop. That's where the potential for differences in tolerance or resistance to the psyllid comes in. And if there are varieties that are more tolerant of the psyllid, then that can be incorporated into new generations to provide more options for growers.
Through my work with Dr. Nick Roscridge and working with Tahuri Whenua and Koanga Gardens up in Northland, I've been able to access over 30 varieties of the 70 that are known. Actually gaining the support of Māori and being able to use their knowledge and combine that with modern science, it's huge for this project, because if we find something, we could potentially breed that back into other commercial varieties and hopefully shift that resistance from this variety to another one. After I finished my BSc, I went on to do a postgraduate diploma. That's where I met Nick. I could see Nick's passion for what he was doing, and he's pretty much the master of his own field. So having access to that huge knowledge base is a major benefit, and he sculpted me into the scientist I am today.
Hei tā tākuta Nick Roscridge, kei te puta ngā hua ki ngā taha e rua i te mahi a tāna tauira o mua.
Well, Aleise, she was a student in plant protection, and then she continued on to do a project which was related to the potato psyllid, which has an interest to the Māori community. And from that project, she developed some input to Taewa Whenua, which is the National Māori Growers Collective. So it's a collective that brings people together, but it's also a place to disseminate information and to gather information and experience and make that experience available to the next generation of land managers, if you like. It's a collaboration. It's all an extension of horticultural research, and her work in particular is an extension of what she was doing as a master's student. And the people at Plant and Food have certain expertise that complements the expertise we have here. She's drawing from not just myself, but from a number of experts, both within Plant and Food, Massey and Taewa Whenua, so they all have something to offer.
After the break, we join Aleise in the fields and look at how, by using scientific monitoring techniques and tapping into the vast knowledge of Taewa Whenua, she's hoping to find a Taewa strain resistant to psyllid. If she can find a Taewa variety that is, it could save the potato industry in Aotearoa millions of dollars. Aleise Puketapu is a scientist working at Plant and Food Research who's been searching to find a strain of Taewa resistant to psyllid infestation. These insects have had a devastating impact on potato and tomato crops since they were first discovered in our country in 2006. If Aleise can find a strain of Taewa that's resistant, it could have an enormous impact on the potato industry and tangible benefits for Taewa growers.
I'm sort of working on both sides of the story. I'm working on the science as well as being an active member of Tahuri Whenua, and I'm also on the committee there. So I'm accountable to the two sides of the story, really. Not every scientist gets to go out into the field and plant seeds and watch their plants grow and help in the harvest as well, so definitely a perk of my job. So I've submitted Taewa cultivars to 2 trials here at Carter's. They're both designed by John Anderson at Plant and Food Research. The first trial is a screening trial to see if there are any sort of characteristics of resistance to zebra chip and psyllid. And the second trial is a yield trial where I've submitted 3 of the most common varieties to that. That's also designed by John Anderson. And what we're doing is exposing those varieties to 3 different management regimes.
Alice's trial tests Taewa resistance to psyllid under different insect control regimes. The full spray regime places the Taewa under little or no psyllid pressure. A mid-spray regime places them under mild psyllid pressure, while a no-spray regime places the Taewa under natural psyllid pressure. By comparing the 3 trials, the natural resistance of specific Taewa varieties can be ascertained.
It's just about expanding the range of what we're looking at. To have worked with both Nick and Tahuri Whenua and sort of gaining their support, and through their network I've been able to access a number of varieties, and even from contacts from there I've been able to contact families in marae that maybe have some varieties that haven't been seen for many years. So it's about broadening the search for resistance. If we don't look, we won't find anything.
Anō mo te katoa o tōna awa, Nick e rangahau ana, e kohi ana I tēnei momo Mātauranga. Kua paihere whanaungatanga ia ki ngā kai whakatipu Taewa o te motu.
So I'm just going to label this variety before it goes into standing out for the collection. It's important that we maintain the genetic diversity between the crop just for future opportunity around pest and disease management, even resistance to some of the management controls, you know, the chemicals in the different sprays, because over time, if they're constantly used, the plant develops resistance. So having that diversity is useful to help respond to that. Internationally, breeding programs rely on the diversity to be able to use different traits to build into the new cultivars that are being grown. In the case of Alice's project, it's really about the response to a new pest that hasn't been in the country until now, and whether these varieties display different characteristics than your modern cultivars, if you like. So it's vitally essential that we keep, I suppose you'd call them heritage cultivars, purely because once they're lost, they're lost. So our job is to maintain it for future generations, and that in the sense of all the work we do, it's about the future, and it's about food security in the future as well.
Kua tino whai hua te kai whakatipu riwa e matua nei a John Anderson I te Mātauranga ira kua kohia nei. E rika ana ia ki te nanao I ngā huarahi maha ki te kimitikanga e whai ārai ai ngā momoriwai katoa ka hokona.
There is a question mark on one of the Taewa lines whether it may have some resistance, and we certainly are using that in the breeding program to a limited extent, and the progeny from that, as well as a whole number of other lines which may have some potential resistance to the psyllid. We're using those as parents and bringing them into environments like this where we're selecting in the field and trying to select varieties which will not show the symptoms of zebra chip. So we have one line, Tirakuri, which appears to have some possible resistance to zebra chip. Can't be certain of that at the moment, but we are certainly using that in our breeding program in an attempt to breed for resistance to zebra chip. It could be very significant, it could be hundreds of millions of dollars, and also at the moment to control the psyllid and control the level of zebra chip, you're getting quite high amounts of insecticide are used, and if we can help reduce the level of insecticide use in New Zealand and overseas, this has a real advantage both environmentally and in terms of the quality of the food, and people feel more confident in the food that they're eating if lower levels of insecticide are used.
So this is the full spray plot for the yield trials. The crop is reaching maturity. It's about 3 months old. Within the next month, the tops will be cut off and they'll be sprayed, and the potatoes will be left in the ground to harden off. If we have a look over here, so these plants have been sprayed off. They'll be left to sit for about 7 days for the skins to harden off before we harvest them. They're not quite ready yet, so I can't show you that. But once we've harvested, we'll take the Taewa back to Plant and Food Research, and that's where I'll do all my testing for resistance.
Kia hauhaketia ngā taiwa, ka hoa atu a Aleise ki te āta wherawhera a pūtaiao i ngā tikanga tauara i te psyllid. Heoi, e hara i te mea kei roa taiwhanga pūtaiao ia, me ki pēnei kei roa kauta ke.
If there is any zebra chip present in the tuber, you can tell just by raw assessment. With Taewa, it's a bit harder because some of the varieties actually have a pronounced vascular ring already, and that's what we're looking at. Mandolins are not your common piece of scientific equipment. Science was a huge part of Indigenous culture. We have rongoa. Our ancestors used to use things like kaukaua as an insect deterrent, so more Mātauranga than anything else. The research that I'm doing is about repatriation, and after I've finished this project, it's about distributing that science and getting the sort of results and everything to the Māori people.
After the break, we move from slicing and dicing to deep frying as Aleise checks a selection of Taewa for resistance to psyllid. Nick Roscrouge hopes Alice's findings are beneficial for growers hoping to rebuild the commercial potential of Taewa. He kai pūtaiao a Aleise Puketapu, searching for a variety of Taewa resistant to the psyllid, a bug that's wreaked havoc with potato and tomato crops. First discovered here in 2006, the insect is decimating potato harvests and causing millions of dollars of damage to the industry. Alice's ability to access the Mātauranga around the Taewa was an enormous asset that her supervisor, Dr. Robin Gardner-Gee, was keen to tap into.
When Aleise started here, one of the things I was really impressed by was the links that she had already built into Māori horticulture, her involvement with Te Huri Whenua, and so I felt that that was just a huge asset for Plant and Food. And so one of the things that I've felt I could do to build her was to encourage her, just to give her the space to keep on maintaining those links, building those links, at the same time as she was building her experiences and skills as a scientist. So it was getting that balance between what she was already bringing in, keeping on growing that, and then what we could offer her as a major research institute, which was access to a whole range of scientists and different approaches and different types of work here.
Nā tēnei Mātauranga pūtaiao, kei te aro matawai a Aleise i te noho mai a te pāra zebra, kua puta nei i te psyllids o ngā Taewa kua kohia e ia.
Okay, now I'm going to get ready to fry these potato slices. First of all, I'll assess them on our raw scale. It's a scale of 0 being clear of any inconsistencies or browning in the vascular ring, and 5 being the worst. Tūtaukuri is probably the hardest to score because of its colour. We're looking for any sort of browning which will become more pronounced when we fry. Browning could potentially indicate the presence of zebra chip. This variety, Mātauranga, there's about 6 scale 1 crisps and a scale 3. Everything I do is based on observation. This process, and when I'm looking out in the field for insects and looking for psyllids or signs of zebra chip, frying and doing the raw assessment is I'd say the quickest way of getting any feedback. And now we're ready for frying. What we're looking for is if there's any sort of browning of the vascular ring. Because Liberobacter convert the starches to sugar, these sugars should burn off first. So when we take them out, we'll see if there's any browning of the vascular ring and possible zebra chip. Doing frying like this is the fastest way of getting any feedback. The only other way is going through DNA processing, which is quite a time-consuming process, whereas this takes 3 minutes and we can put through as many varieties as we want. I suppose there are many facets of science, from your backyard science right through to your high-tech PC2 lab or something like that. Yeah, but here we have our deep fryer, so that's our most technical piece of equipment. So what we're looking for is any browning of the vascular ring. See here, that would be a 0. This one here, on our scale, which is up on the wall, would be a 4, I'd say. This is the second year of a 2-year trial. If there are any varieties that show some sort of resistance, we'll have to look at it in depth after that, probably another 2 or 3 years of trials. And then from there, if there is any true resistance, we'd have to report back to Potatoes New Zealand and Plant and Food Research, look at the possibility of using that variety as a parent. So if we did find a resistant variety, it would have a profound effect on the world. You'd see benefits in North America, South America, Hawaii, and wherever else the potato psyllid may venture in the future.
E tūmanako ana Nick, mā te Mātauranga nei, ka ora te Taewa hei tipu tau hoko kokoru. E aro nui ai hoki ngā kaiwhakatipu ki ngā momo e kaha ana ki te ārai psyllid.
This sort of research is, well, it's important, certainly for commercial opportunities, because the psyllid has the ability to drop yields by about 80%. So Alice's work contributes to our understanding of these crops. This is the Taewa Māori. And all of the outputs of her work will help growers do a better job effectively of their crop. And at the end of the day, it's about being economic, and it's about having a crop that is suitable for the market. It's important also that students like Aleise or when they've graduated and they become part of the workforce are picked up by research institutions like Plant and Food, because they've got so much to offer. And in Alice's case, it's that understanding of plants, understanding of plant protection, but it's also the ahua Māori, you know, the Māori purpose about her approach to science and her interpretation of science. And because these crops are being grown as a kaupapa Māori initiative, so they're grown by Māori growers on Māori land with a Māori future in mind, then having someone like Aleise in the system is a huge opportunity. We need more of them. We haven't got enough young Māori doing science, and Aleise is an excellent example of where you can go.
I think I'm very lucky to work on both sides of the story. On one hand, I have the Māori value system, because that's who I am. I have my own value system as well, and then I have my teachings, my science and everything like that. I'm hoping my role within Plant and Food Research as a Māori scientist will bridge the gap between Māori and research scientists, and hopefully we can ultimately come together and end up with some really positive benefits.
Alice's trials will feed into Plant and Food's fight against the psyllid, and the results could have global consequences. Her research could help save millions, if not billions of dollars for the industry in lost yield, as well as lessening commercial growers' reliance on pesticides. And for Taewa growers, the information she gains could help this taonga crop reach its commercial potential.